Hello buddies, welcome back. This is Sidhu from Sri Chaitanya Educational Institutions, Gosala. I am the senior lecturer in chemistry. Today we are discussing about another important topic in NEET chemistry syllabus, that is classification of and periodic properties of the elements. Classification and periodic properties of the elements. So this is one of the important topic, very basic topic in first year. However, the periodic properties will be covered in second year syllabus also. As we know that in NEET, the main core chemistry of P block has been deleted. So in P block of class 11th as well as 12th, boron family, carbon family and nitrogen family, oxygen family, halogen family and noble gases. Also S block elements and hydrogen has been removed. But we need to learn about their general properties. Therefore, this topic is related to all the properties of elements of the periodic table. Therefore, we need to learn a little more about the properties in this topic. Let's go for the questions in this topic. Look at the first question. It is about the Dauberner's law of triads. So in NEET syllabus, it is mentioned that we have to start in the official document. It is mentioned that we have to start from modern periodic table. But sometimes there is a chance that the examiner will ask about the genesis of periodic table. That means how the periodic table is developed. So Dauberner law of triads is one of the proposal made by him. What is that? We know that some elements arranged by Dauberner, a set of 3 elements called triads, and it is found that the properties of the middle element are average of the properties of first element and third element. So that is the Dauberner's law of triads. In that, there are certain sets. For example, if you take this question, let's go for the question once. The atomic masses of lithium and potassium are given as 7, 30, 9 respectively. According to the law of triads by Dauberner, the atomic mass of sodium will be. Simple question. Simply we will get the average of the atomic masses of lithium and potassium. Let's see. This is the triad, lithium and then sodium and then potassium. What is the lithium atomic mass given? Lithium atomic mass given as 7 and potassium atomic mass is given as 39. Then what is the average of the 7 and 39? That is 7 plus 39 divided by 2. 46 divided by 2. Then what is its value? 23. So what is the atomic mass of sodium? Obviously 23. This proves that there is the chance that suppose if you arrange some elements in the form of triads, there is a chance that the average properties of the first and third element can be similar to that of the second or middle element. Let's go for the next question. This question is also similar to the previous question, but the format is different. Let's go for the question, what it is mentioned. 3 elements X, Y and Z have atomic numbers 19, 37 and 55 respectively. Then the correct statements is or are. It's like multi-correct. Let us see. X, Y, Z have atomic numbers. So what are those atomic numbers? Let us see. 19. If it is 19, can you guess the element? You must have command on atomic number and corresponding element. The element here it is potassium. Atomic number 19, element is potassium. Then atomic number 37, can you guess? It is rubidium. Atomic number 55, what is this? Obviously cesium. So all are alkali metals. Now what they are asking in the problem, the options if you see, first option is their ionization potential would increase with increasing atomic numbers. Let's see what happens to the trend of ionization energy. The trend of ionization energy, if you see down the group, ionization energy down the group decreases. Do you agree with that? Yes, that is the general trend. And also in alkali metals, we don't find any exception. Ionization energy decreases down the group. What it is mentioned there? Let us see. The ionization potential would increase with increase in atomic number. Therefore, obviously it is a wrong statement. It is a wrong statement. Let's go for option B, statement B. Y would have an ionization potential between those of X and Z. Obviously, it looks like the right option. Y would have, what is Y here? The rubidium. The ionization energy of the middle element is average of or in between, okay, the potassium and cesium. Obviously, no? So what is the actual trend of ionization energy? The actual trend of ionization energy is potassium greater than rubidium greater than cesium. So what is the statement? The ionization energy of Y. Here what is this? Kx. What is this? Rubidium, that is Y, and this is Z. The ionization energy of rubidium, that is Y, is in between potassium, that is X, and cesium, that is Z. Right statement. Look at that. Y would have an ionization potential between those of X and Z numbers. That is right statement. Let's go for the next statement. Y would have highest ionization potential. Wrong. Just now we have discussed. If option B is right, option C is obviously wrong. And Z would have the highest ionization potential. As we know that down the group ionization energy decreases. Here cesium has the lowest ionization potential. Therefore, what is the right option? The right option is only one, that is option B. I hope we are clear with this. Let's go for the next question. This question is about again ionization potentials only. However, general trends we learn about ionization energy 1. What is the trend? But here the question is about ionization energy 2. That means second ionization energy they are asking. Look at the question. The second ionization potential value is lowest for they are asking. First, let us see first ionization potential about the above elements. What is the order of first ionization potential? We know that left to right ionization energy, okay, ionization energy increases, that we know it. And also we know that metals like alkali metals and alkaline earth metals do have lower ionization energy, and non-metals have more ionization energy. In the given list, suppose if they ask ionization energy 1, which will have the lowest sodium, being an alkali metals, then can we expect it is magnesium? Yes. After that we will have oxygen, after that we will have fluorine. This is ionization energy 1. That we can easily do it. But they are asking the second ionization potential value, that to lowest for they are asking. Can you guess what is the second ionization energy trend here? Let's guess the second ionization energy trend. The second ionization energy means here we have to see the electronic configuration of the cation, mono positive or uni positive cation. Now let's see what is the stability. Na plus, what is its configuration? Neon. Na plus has the neon configuration, the stable configuration. Therefore, Na plus, it has the highest ionization energy, or simply we can say that IE2 of sodium. Again I am telling IE2 of sodium is very high here in the given options. So that means sodium here will get like this. IE2 of sodium is high because Na plus is more stable. So why Na plus is more stable? Because it has the noble gas configuration. Now let's go for the next one. Obviously, after sodium, what we can expect? Can we get the magnesium? No, we don't get, because magnesium plus, what is the configuration? Magnesium plus configuration is neon, and then we'll get 3s1. That means it is like now, okay, sodium configuration. Now let's go for the next. O plus, what is its configuration? Helium. O plus have 7 electron system now. That means it has like nitrogen stable configuration, stable half-filled configuration. Then after sodium, the second ionization energy, what we can expect? We can expect oxygen, not fluorine. Oxygen will have more second ionization enthalpy because O plus has the highest stability compared to the F plus. Then we will get fluorine, and then we will get magnesium. Let me write fluorine configuration also, F plus configuration. that is helium 2s2 and 2p4. So now let us see what is the most stable cation, unipositive cation here, Na plus, then O plus, then F plus, and then you can say Mg plus. It's not about stability here, it's about actually the effective nuclear charge also. Fluorine being a non-metal, it has more effective nuclear charge compared to magnesium. Therefore, fluorine has second ionization energy, has highest value compared to magnesium. But O is greater than F because O plus has the stable half-filled configuration of 2s2, 2p3 especially like nitrogen configuration. So this is the question. We can expect this type of questions also in the NEET examination. Let's go for the next question. The next question is about again ionization energy, but I have given the random elements of which group? The elements of 14th group. So in general, ionization energy 1, if you go for down the group, what happens? Down the group, ionization energy decreases as the size increases. Even the effective nuclear charge increases, here size outweighs the effective nuclear charge. That means size increases, ionization energy decreases. So size dominates down the group, that we know. Therefore, in case of alkali metals, we don't find any exception. Down the group, ionization energy decreases. Alkaline earth metals, yes, we don't find any exception there. But we see the exceptions from boron family onwards. In boron family, there is an exception of ionization energy 1. Let's see, in case of boron family, what is the trend of ionization energy 1? Boron family. So we know that boron is greater. So after boron, what we get? After boron, we expect aluminum, but what will get? Thallium. Thallium has the highest ionization energy, second highest ionization energy, we can say, in the boron family. Why? Very famous reason is there. What is that? Due to poor shielding 4f electrons. Due to poor shielding 4f electrons, effective nuclear charge is more here. Therefore, thallium has second highest ionization energy. And then after that, what will get? Gallium. Again, why gallium? Due to poor shielding 3d electrons. Here, poor shielding of 4f electrons is there. Poor shielding effect of 4f electrons is there. Here, poor shielding effect of 3d electrons is there. Okay, 3d electrons is there. Then what we get? Then we will get aluminum, and then we are going to get indium. So this is for boron family. So here we are getting the irregular trend. And another irregular trend we observe for the carbon family also. Another irregular trend we observe for the carbon family also. In case of carbon family, what is the trend we get? In case of carbon family, what is the trend we get? In case of carbon family, here if you go for carbon has the highest obviously. So after that what will happen? What we guess? After that we will get silicon, and then we will get germanium. Sir, we don't find any exception. Let's see. And then what we will get? Tin. And then we will get lead greater than tin. Lead greater than tin. Lead ionization energy is more than tin. Now exact trend if you want, carbon greater than, silicon greater than, germanium greater than, lead greater than tin we are going to get. Lead ionization energy is greater than tin. Lead ionization energy is greater than tin. So actually here, due to the poor shielding of 4f electrons, due to poor shielding of 4f electrons, effective nuclear charge is more in case of lead. Therefore, lead ionization energy is more than tin ionization energy. Now the question is, which among the following elements have the lowest value of IE1? So what is the answer? The answer will be not lead. The answer is actually tin, option B. I hope we are clear with this. These are the two important exceptions, boron family and carbon family. You need to know. Is there any exception in nitrogen family? No. Is there any exception in oxygen family? No. Is there any exception in halogen family? No. Is there any exception in noble gases? No. That means in groups, there are two important exceptions are the trends in ionization energy. One is boron family, another one is carbon family. Coming to memorize this. Let's go for next. The correct order of Pauling's electronegativity is. Generally, electronegativity trends should be remembered. What is the trend? In a period, electronegativity increases. in a group, electronegativity decreases. Here also we observe the exceptions. Before going to the exceptions, let's see the question. They have asked the correct order of Pauling's electronegativity. They have given elements of first and second period. We know that generally non-metals have more electronegativity. So obviously we will get carbon is having more electronegativity. But what is the value? Sometimes it is better to remember the values also. Value of carbon is approximately 2.5. After carbon, what is the next one we will get? You will have a confusion about either boron or hydrogen. We see sodium borohydride we call it. What is the meaning of it? Here hydrogen is in the form of anion. So what is the meaning of it? Hydrogen is more electronegative than boron. So hydrogen, boron. What is the value? 2.1 and what is the value? 2.0. So that means here the carbon is more electronegative, that we know. We are 100% sure with two options C or D. Then we have a trouble with boron and hydrogen. Here hydrogen is more electronegative than boron. Now what is the most electronegative element that we know? What is that? Fluorine. And then oxygen. No issue with that. Are you clear with this? Now is there any exceptions in electronegativity of in the trend? Yes, we have the exceptions. Down the group generally electronegativity decreases. First group we don't have any exception. Second group also we don't have any exception. The 13th group or boron family we have the exception. So what is the trend we will get for electronegativity of the boron family elements? The boron family elements if you go for, so generally here highest electronegativity for boron, that we agree. After boron what we should get? Aluminium. But here aluminium having less electronegativity. So then here electronegativity decreases up to aluminum, then it increases. That means here aluminum, then gallium less than, indium less than thallium we are going to get. So that means electronegativity decreases first, then increases. If you see the values also, so let's see the values here. Boron value is how much? The boron value is 2.0, aluminum value is 1.5, gallium 1.6, indium 1.7 and thallium 1.8. That means electronegativity versus atomic number plots if you go for, first it decreases and then it increases. So let me write it. So first it decreases and then it increases. So this is boron and this is aluminum and this is gallium and this is indium and this is thallium. We are going to get it like this. Is there any exception? Any other exception? Yes, we have another exception, that is in carbon family. In carbon family, what is the trend we will get? Let's see that values also. Here, down the group, ionization energy should, electronegativity should decrease. So now, what happens to the carbon family? Let's see. So in case of carbon family, the trend will be like this. In case of carbon family, the trend will be like this. Here, the carbon family, we go for, first carbon is greater and then silicon is almost equal to germanium, is almost equal to tin, which is almost equal to lead. But exact values if you see, carbon is 2.5, silicon is 1.8, 1.8 and this is also 1.8. Lead is slightly higher than tin. Exact values if it is given like this. General statement it is given like this. In case of carbon family, electronegativity first decreases and then remains constant. Is it right statement? Yes. Almost constant, it is right statement. But at the same time, if they ask the trend, carbon greater than silicon. Okay, then what I have to write? Instead of silicon, I am writing lead. Carbon greater than, lead greater than, and then silicon is approximately equal to, germanium is approximately equal to 10. That means here lead is slightly higher than the three elements silicon, germanium and tin. So these are the two important electronegative exceptions you need to know in case of the groups. Let's go for the next question. Next question is a combination of all the properties. Let us see which of select the incorrect statement in the given list. So IE1 of helium is greater than that of neon. Obviously, down the group for noble gases, if you go for ionization energy, okay, decreases down the group. Obviously, helium will have more ionization energy than neon. Right statement. Let's go for next B. Chlorine has greater electron affinity than fluorine. Obviously, that is well known statement. This is IE1. A is right, and then electron gain enthalpy or electron affinity. Okay, electron affinity they are asking. Electron affinity. So obviously fluorine, electron affinity, right? So EA, electron affinity. So chlorine has greater electron affinity than fluorine. This is well known. Generally we expect fluorine has more electron affinity, but chlorine, because due to small size, the interelectronic repulsions are more in fluorine. Due to this, the incoming electron is opposed by the inner core electrons. Therefore, fluorine electron affinity is less than chlorine. Let's go for next, option C. It's about acidic strength. As we know, the acidic strength of oxides or oxoacids. What is the trend? The acidic strength is directly proportional to polarizing power. Is directly proportional to polarizing power of central cation. Polarizing power of central cation. In case of oxides and oxoacids, we can apply this. So higher the polarizing power, higher the acidic strength. So here the polarizing power is directly proportional to charge, inversely proportional to radius square. Simply, acidic strength is directly proportional to the charge. Acidic strength is directly proportional to the charge. So here inversely proportional to radius square. So here charge is more for what? The chlorine. The charge is more for what? The charge strengths, if you see. In case of perchloric acid, what is the charge of chlorine? +7. In case of this is perchloric acid. In case of chloric acid, what is the charge? +5. In case of chlorous acid, what is the charge? +3. In case of hypochlorous acid, what is the charge? +1. So higher the charge, higher the acidic strength. That means here, which should have more acidic strength? Perchloric acid. HClO4 should have more acidic strength, but unfortunately they have given opposite trend. Therefore, what is the incorrect option? Option C. Let's see the option D also once, what they have mentioned. There are 32 elements in period number 6. Obviously, 32 elements are there in period number 6 in periodic table. So now option C is incorrect. Here acidic strength order is HClO4 greater than HClO3 greater than HClO2 greater than HOCl. They have given opposite trend. Let's go for the next question. This question is about electron affinity. Interestingly, here I don't give the normal elements. I have given the ions. So it's about, okay na, it's not just about what you learn. It's about the thinking process. So let's see the question. Which of the following has the highest electron affinity? F minus and Cl minus, Na plus and Li plus. So generally what you go for the option? Option you go for Cl minus. That is wrong. Cl has highest electron affinity, not Cl minus. Cl minus already gained the electron. It is negatively charged. How can a negatively charged species again gain one more electron? It's not easy to add an electron to an anion. So electron affinity is there for cations, not for anions. Now in this problem, if you go for Cl minus, you will get -1 mark. So be careful. So here electron affinity is tendency to attract the electron. It is calculated in the form of an energy value. Okay, we know that. So here cations have high electron affinity than anions. Anions do not have electron affinity. They don't want to gain the electron. So eliminate the option A and option B. F minus and Cl minus we need to eliminate. Then among the two cations, which has more electron affinity? Here, if you take lithium plus, it is smaller in size. Lithium plus is smaller in size. Na plus is bigger in size. As we know that smaller the size, higher the electron affinity. Easy. You can easily do the problem. So lithium plus has higher electron affinity than Na plus. Or you can just take electron affinity has opposite value of ionization energy. You can take like that also. Suppose if you assume like this. For example, if I take lithium, if I remove an electron from lithium, this is ionization. Yes or no? Li plus and electron. This is ionization of lithium, which is actually ionization energy, which is a positive value. Now sodium loses an electron and convert into sodium plus. Now tell me, which has highest ionization energy, lithium or sodium? Lithium. That means it is difficult to remove the electron from lithium. What is the opposite statement we can say? It is easy to add the electrons to lithium plus. It is difficult to remove the electron from lithium, but it is easy to add the electrons to lithium plus. That means which will have high electron affinity? Obviously, lithium plus. So simple, the conclusion is that anions do not have electron affinity. We can eliminate the two options, and cations have electron affinity. In that, the smallest cations have the highest electron affinity. This is a different question. Okay, let's go for the next. This is about radius that we know. Okay, general trend, if you go for the radius, down the group radius increases, left to right in a period radius decreases. Now, if you go for the question, the trend of ionic radius they are asking. Now, if you see that there is lithium, there is sodium, and this is beryllium, and there is magnesium. If you take these atoms, can you guess the trend which is the biggest one? So, obviously here if you see lithium, beryllium, let us compare. Lithium is bigger than beryllium, and down the groups sodium is bigger than lithium, and sodium is also bigger than magnesium. Magnesium is bigger than beryllium. So, it is like this. Now, the conclusion is that here atomic radius if you consider, which is the biggest one? Sodium. Down the group size increases and the left to right size decreases if you consider. Then after that what we will get? After we will get that we will get magnesium. Okay. Then we will get lithium. Then we will get beryllium. So generally third period elements have more bigger radius than second period elements. This is the general trend that we know. But the question is not about atomic radius, they are asking ionic radius. Of course, it has to follow the same trend. Yes or no? But that is not correct. There is a twist in the problem. It is actually data-based problem. That data is clearly presented in NCERT textbook about the atomic radius of these four elements. So now, if you see that the actual trend of ionic radii, here this is lithium plus and then beryllium 2 plus. Obviously, lithium plus is more than beryllium 2 plus, but we know higher the charge, lower the size. And then Na plus is obviously bigger than lithium plus. At the same time, Na plus is bigger than magnesium 2 plus and magnesium 2 plus is bigger than beryllium 2 plus. This is okay. Whatever I have written, it is okay. It is matching. But if you see the exact values, here sodium plus is bigger. After that, what we expect? Magnesium 2 plus. No. This lithium plus is bigger than magnesium plus. Due to high charge, the size reduces significantly. If you see the data, it is approximately, I think, this is 76 picometers and this is 72 picometers. They are very close. There is a small difference between both of them. In fact, due to this small difference, there is similar radii, they show the diagonal relationship. But if you want the exact values, lithium plus is bigger than magnesium 2 plus. Due to high charge, magnesium 2 plus size is smaller. So, very important question. And this data is clearly mentioned in the NCERT, okay, in the ionic radii topic. Let's go for the next question. Let's see the next question. This is also about all the properties, mixed properties. Look at the first statement. What is the question actually? The incorrect order of properties given in parenthesis are, that is, electron affinity for the first option, chlorine greater than, sulfur greater than, fluorine greater than, oxygen. Let's see, we may take it as the right option. But if you see in the 17th group, the halogen family, what is the electron affinity order? Chlorine greater than, fluorine greater than, bromine greater than, iodine greater than, acetate. Down the group, electron affinity decreases, that we know it. But here, due to interelectronic repulsions in fluorine, the electron affinity is little less compared to chlorine. What about the 17th group, 16th group, oxygen family? Here we will get what we expect should be sulfur, okay, greater than, we should get oxygen, right? No. What is the trend? We will get sulfur greater than, selenium greater than, tellurium greater than, polonium greater than oxygen. Oxygen has the least electron affinity in the chalcogens or oxygen family. Why so? Why fluorine second rank? I have explained. Due to small size, interelectron repulsions are more. Why can't oxygen get the second rank? Oxygen also the same reason. Due to interelectronic repulsions, its electron affinity is less, but it is least in the particular group, corresponding group. Why? Because fluorine, after gaining one electron, it converts into a noble gas configuration. It gets the noble gas stable configuration. However, oxygen, after gaining only one electron, there is no use. It needs to gain two electrons to get the stable noble gas configuration. Therefore, oxygen electron affinity is least in the 16th group. So now if you compare both, which will have highest? Obviously, halogens outnumber the chalcogens in case of the electron affinity. If you go for the net trend, chlorine greater than, fluorine greater than, bromine greater than, iodine greater than, astatine greater than, sulfur greater than, selenium greater than, tellurium greater than, polonium greater than, oxygen. So chlorine has highest here in these two groups, oxygen has the least value. If you compare chlorine, then what should we get? Fluorine. But what it is given there? Sulfur. So obviously that is the incorrect option. So option A itself is incorrect. However, let us see the rest of the options also. Now let's go for option B. Ionization energy 2. Ionization energy 2. So we know that ionization energy 1 order, if you go for in the given list. So which has highest ionization energy? Fluorine. Then oxygen will get. And then we'll get carbon and boron. But IE2 is given. To know the IE2 trend, we have to know the stability of monopositive cation or unipositive cation. O plus, what is its electronic configuration? Its electronic configuration is 2s2 2p3, nitrogen configuration or half-filled p orbitals are there. Now F plus, what is its electronic configuration? 2s2 2p4. Then we have B plus, what is its electronic configuration? 2s2. And then we have C plus, what is its electronic configuration? 2s2 2p1. If you consider this, what is the most stable one here? O plus. So oxygen has the highest second ionization enthalpy, right? After oxygen, we will get fluorine because effective nuclear charge, obviously we need to see that. Okay, effective nuclear charge is more for fluorine. So oxygen and fluorine. Then compare boron and carbon. Boron has fulfilled orbitals 2s2. Therefore, boron is greater than carbon in case of ionization energy 2. Therefore, option B is right statement. Let's go for IE1 of nitrogen, oxygen, phosphorus and sulfur. Here IE1 again stability if you see. Nitrogen, oxygen, we expect oxygen should be more than nitrogen because left to right ionization energy increases. But here nitrogen has stable configuration. Nitrogen has 2s2 2p3 configuration. Therefore, nitrogen is greater than oxygen. That we know. Then similar reason if you go for phosphorus greater than sulfur. That also we know. But if you compare these two, 4 elements, then second period elements, the small elements have more ionization energy. Therefore, nitrogen greater than oxygen, then greater than phosphorus, then sulfur. Therefore, option C also is a right statement. Let's go for option D. Option D about electron affinity of different elements given. So, in the period, electron affinity, we know that it increases. However, nitrogen and beryllium have stable configuration. They don't want to gain electron. They have positive electron gain enthalpy. Their electron affinity is actually negative. They don't want to gain the electron because they are already having stable configuration. So nitrogen is least. After that regular trend only we will get oxygen greater than, carbon greater than, boron greater than nitrogen. So option D also correct. So what is the incorrect option? Option A. I mean incorrect trend, option A. So option A is the right option. Okay, let's go for the next. The next question is about the comparison of the trends. Let us see. The atomic number of elements of A, B, C, D are given. A is Z minus 1 atomic number, and then B is Z, okay, and then C is Z plus 1, and then D is Z plus 2. So these are the atomic numbers. Then what is mentioned? If B is a noble gas, B is a noble gas, we can put an analogy. B, let us take it as neon. Let's compare. Let us assume B is, okay, neon. B is neon. It is a noble gas. Then what is Z minus 1? Before neon, what we get? Fluorine. So A is fluorine. And then what is Z plus 1? Neon plus 1 element. 11. Okay, that is atomic number 11. What is that? Sodium. And then atomic number 12. What is that? Magnesium. So with this analogy, with this comparison, we can do the, okay, we can check the options and then we can check the properties. Option 1, statement 1 they have mentioned, A has higher electron affinity. A means here what? Fluorine. In the given elements, in the given list, fluorine obviously has a high electron affinity. Therefore, obviously, first statement is right. Then, 2. C exists in +2 oxidation state. What is C here? Sodium +2. Wrong. Sodium is not showing +2. Sodium shows +1. And D is an alkaline earth metal, magnesium. Okay, right only. So that means here D, that is statement 3 is right. D is an alkaline earth metal. Statement 1 is right. A is a fluorine, that is high electron affinity. And statement C, that is statement 2, that is C exists as +2 is wrong. Therefore, 1 and 3 are right. 1 and 3 are right means what is the right option? The right option is option C. But this is the comparison of the properties. Let's go for next. The next question is a statement based question. Let us see the statements. Given below are two statements. Statement 1 is the electronegativity of group 14 elements from silicon to lead gradually decreases. If you remember, I have given about electronegativity trend. From carbon to silicon, electronegativity decreases, and then electronegativity becomes almost constant. Carbon and then silicon is equal to germanium is equal to tin is less than or equal to lead. This is 2.5, this is 1.8, 1.8, 1.8 and this is 1.9. Are you clear with this? So, statement 1 is wrong. They are telling gradually decreases. Statement 1 is wrong. False. Next, group 14 contains non-metallic, metallic as well as metalloids. Obviously, na? Group 14, what is non-metal in that? Carbon. Metalloids, silicon, germanium and metals, tin and lead. So, statement 2 is right. Statement 1 is wrong. Statement 2 is right. Statement 1 is false. Statement 2 is true. Therefore, what is the right option? The right option is option 3. Let's go for next question. Given below are two statements. This is also assertion reason type question. So, given below are two statements. One is labeled as assertion A and another is labeled as reason R. What is that assertion A? The first ionization enthalpy decreases across a period. Let us see the reason. The increasing nuclear charge outweighs the shielding across the period. Then, in the light of above statement, choose the most appropriate option. Both assertion and reason are true and R is correct explanation of A. Assertion. Both assertion and reason are true and but R is not the correct explanation. And assertion is false, reason is true. Assertion is true, reason is false. Let's see the assertion once again. First ionization enthalpy decreases across a period. Wrong. First ionization enthalpy generally increases across a period because the increasing nuclear charge outweighs the shielding across the period. So, reason is correct. Assertion is wrong. So, reason is true. Assertion is false means what is the right option? Option 3. So, what is the actual thing, actual proper answer or proper correct information here? Assertion should be like this. The first ionization enthalpy increases across a period because the increasing nuclear charge outweighs the shielding across the period. So, that is the way to ask the question. Let's go for next. Again, statement based questions. Let us see the first statement. The fluorine has most negative electron gain enthalpy in the group. Obviously, in the group. Oh no, let's see. Fluorine has most negative electron gain enthalpy. Wrong, na? What is the which has most negative value in that particular group? Chlorine. Chlorine greater than, fluorine greater than, bromine greater than, iodine greater than, acetylene. Wrong statement. Oxygen has the least. Obviously, just now we have seen. Sulfur greater than, selenium greater than, tellurium greater than, polonium greater than oxygen. Oxygen has the least value of electron, negative value of electron gain enthalpy. So, first statement is wrong, second statement is right. Statement 1 is false and statement 2 is true. So, here options are jumbled, be careful. So, be careful. Statement 1 is false and then statement 2 is true. So, first option 1 is the correct option. Let's go for next. Again, two statements are there. Along the period, the chemical reactivity of elements gradually increases from group 1 to group 18. Let's see. Statement 2. The nature of oxides formed by group 1 elements are basic, while that of group 17 elements are acidic. If you see the chemical reactivity in a period has some irregular trend. Down the group, no issue. We can say, chemical reactivity, especially if it is metals. So, chemical reactivity increases. Down the group, chemical reactivity increases. But in case of non-metals, chemical reactivity decreases. Here in a period, what happens is, here at the beginning, the metals are more reactive and then the reactivity slowly decreases and again it increases. That means reactivity first decreases and then again increases. We get a pattern of V in case of reactivity. General trend, reactivity, reaction with air or reaction with water. General trend I am talking about. So metals are extremely reactive and then reactivity slowly decreases and then again increases. Here there is no gradual decrease or gradual increase. Therefore, first statement is wrong. The nature of oxides formed by group 1 elements. We know that left to right what happens to the acidic strength. Acidic strength increases, basic strength decreases. For example, Na2O is a basic oxide that we know. MgO is also a basic oxide. These two are basic oxides. And Al2O3 is amphoteric. That means basic nature decreases. Acidic nature increases. SiO2 is weakly acidic and P4O10 is weakly acidic. SO3 is strongly acidic. Cl2O7 is also strongly acidic. So what is the order of acidic strength? What is the order of trend we are going to get here? Let me explain. So here Na2O is basic, strongly basic. MgO is weakly basic. Okay, weakly basic. Al2O3 is in fact amphoteric. SiO2 is weakly acidic. And P4O10 also weakly acidic. SO3 is strongly acidic. And Cl2O7 also strongly acidic. So here alkali metals form most basic oxides and halogens form most acidic oxides. Now look at the nature of oxides formed by group 1 elements is basic, right statement, and that of group 17 elements is acidic, that is also right statement. So therefore statement 2 is right, but statement 1 is incorrect. What is the right option? Let's see. Statement 1 is false and statement, okay na, statement 2 I think. Statement 1 and 2 are false. Actually statement 1 is false, but statement 2, this is statement 2 is true. Let's go for next. The correct sequence of electron gain enthalpy of elements. Again electron gain enthalpy, but they have given, okay na, different options and different elements randomly they have given. So please be careful. This is, they don't mention negative value. This question looks easy, but many of them do the mistake. They don't mention the value. They have simply mentioned the correct sequence of electron gain enthalpy. Negative value they don't mention. That means we need to take the sign into consideration. Very, very important. We need to consider the sign into consideration. Here, highest value means higher positive value. Lowest value means higher negative value. Now, we know that electron gain enthalpy is positive for argon. Negative and negative and negative. That means which has the highest electron gain enthalpy? Argon. A is greater. So you do the mistake by considering it as fluorine as the most one. But here they don't mention it is negative electron gain enthalpy. They mention simply electron gain enthalpy. Therefore, you have to be careful. So argon has the highest value because positive value more than negative value. After argon, which has the lowest value? Can you guess if you do understand this? Fluorine. Fluorine has the most negative electron gain enthalpy, means the lowest electron gain enthalpy in terms of value. That means fluorine here will get, fluorine means option C will get here. Option C will get here. This is option C. And after fluorine, which has more electron negative value, sulfur. Bromine is there. Bromine means here we'll get option B. And then we are going to get sulfur, option D. So this is argon, positive value. And then the next one sulfur. And the next one bromine. And next one fluorine. So fluorine has the, in the given list, has the more negative value, means least electron gain enthalpy. So to avoid this confusion, that's why the electron affinity term is introduced. Negative, positive confusion is there. It's difficult to compare. Positive value, negative value is there. If you consider electron affinity, what is the trend? Directly we can say fluorine is more electron affinity than bromine. This is about electron affinity. And then we are going to get sulfur, and then we are going to get argon. So that's why electron affinity is introduced to avoid the confusion. You can easily compare. So here they are asking simply electron gain enthalpy. They don't mention that it is negative value or positive value. So argon A greater than, then sulfur D greater than, then bromine B greater than fluorine. So what is the right answer? ADBC. If you see the second option, that is exactly opposite. That means we will get electron affinity. This question is about electron gain enthalpy, and they don't ask, okay, the elements in a single group. They have asked random elements. What are those elements? Argon, bromine, fluorine, sulfur is given. Please look at the statement. The correct sequence of electron gain enthalpy of the elements listed below is. Here they don't mention negative value of electron gain enthalpy. They simply mentioned electron gain enthalpy. That means we need to include the sign also. So simply higher the positive value, higher the electron gain enthalpy. Higher the negative value, lower the electron gain enthalpy. Now if you see, argon will have, do have positive value, and bromine negative, and fluorine also negative, and sulfur also negative. Which has the most negative value? Fluorine, right? We know it, fluorine. That is C. Now second most in this list, bromine. That is option B. And the next one is sulfur. That is option D. And then argon do have positive value. That is option A. So argon has positive value. That means electron gain enthalpy is more for argon than sulfur, than bromine, and then fluorine. Many of students do mistake by taking fluorine has the most value. Fluorine has most negative electron gain enthalpy. Be careful. So they don't mention negative value. They simply mention electron gain enthalpy. So to avoid this confusion only, we have electron affinity. The concept is introduced. Electron affinity means which has the more tendency to gain electron. So electron affinity you can easily identify. What is the, which has the more electron affinity? Fluorine. Then bromine. Then sulfur. Then argon we are going to get. So with electron affinity, okay, fluorine is more. We can easily identify the option. What is the option? C. Then we will get B. I mean to say here the trend, okay, C greater than, B greater than, and D greater than A. C, B, D, A. With electron affinity, this is the trend we will get. But they don't ask electron affinity. They have asked electron gain enthalpy without any sign. Okay, na? With sign, sorry, extremely sorry. So with sign we need to count. If they mention negative, then no problem. Same trend we are going to get. Okay. Fluorine has more negative value. Then bromine, then sulfur, then argon. So be careful with that. So there is another option also. So this is not correct actually. The correct answer is A greater than, D greater than, B greater than C. Let's go for next. Another statement. Both metals and non-metals exist in P and D block. In a hurry we do that. Okay, maybe it is the right option. Look at C. D block non-metals. Is it sinking? No. All D block elements are metals. Therefore, option 1, statement 1 is incorrect or false. Let's go for next. Non-metals have higher ionization enthalpy and higher electronegativity than metals. Obviously, that is right only. Generally, non-metals do have more electronegativity, more electron gain enthalpy, negative value, more ionization energy. So, this is right statement and this is wrong statement. So, don't do the silly mistakes. So, D block only have metals. There are no non-metals in D block. P block, yes, metals are there, non-metals are there, as well as metalloids. Let's go for the next. The characteristics of elements X, Y, Z with atomic numbers respectively 33, 53 and 83. We have already seen this type of problem. Let us see the statements. So, here 33 and then 53 and then 83. With this we need to first have command on atomic numbers and then element. 53 is very famous. What is that? Iodine. That we are clear. Then what about 83? That is bismuth. What about 33? That is arsenic. Now tell me, what are they? We are 100% sure that arsenic is a metalloid. So X is a metalloid. We got the answer, it seems. Then Y is a non-metal, iodine, and Z is a metal. We got the answer. Simple. Answer is simple when you identify the element. Answer is difficult when you don't identify the element. So here the key point is identifying the element only. So arsenic 33 atomic number is a metalloid. Iodine 53 atomic number is a non-metal, and bismuth with atomic number 83 is a metal. Let's go for next. Again similar type of problem. Let us see. 3 elements X, Y, Z are in third period of the periodic table. The oxides of X, Y, Z respectively. Third period X, Y, Z in a sequence. So they have mentioned. So this is X, this is Y, and this is Z. The first one is basic oxide. This is basic oxide. The next one is amphoteric oxide and the next one is acidic oxides. Can you guess these elements? For example, third period they have mentioned. Amphoteric means you should get this is aluminium. So Al2O3, the oxide is Al2O3, and then acidic is silicon dioxide, and then basic is magnesium oxide. You can easily guess it. So as in a period, as the atomic number increases, acidic strength increases. Acidic strength increases. So what is the order of atomic number? So more the acidic nature, more the atomic number. So here atomic number orders they are asking. Z is acidic, that means Z will have highest atomic number. After Z, Y, and then we are going to get X. So what is the right answer? Option D. The next question is about comparison of ionization enthalpy of boron and beryllium. Let's see. Boron has smaller first ionization enthalpy than beryllium. Obviously, you know that ionization energy, one trend if you go for. Here lithium smaller than, boron smaller than beryllium. Beryllium electronic configuration is 2s2, boron electronic configuration is 2s2, 2p1. Beryllium has a little stable configuration. Now, consider the following statements. What is correct we need to identify. Statement 1. It is easy to remove 2p electron than 2s electron. Obviously, 2p electron is little far from the nucleus compared to 2s electron. Right statement. 2p electron of boron is more shielded from the nucleus by the inner core of 2s electrons of the beryllium. 2p electron of boron is more shielded from the nucleus by the inner core of electrons than the 2s electrons of the beryllium. So that's why the boron has less ionization energy than beryllium. That is also right statement. 2s electron has more penetration power. That is what penetration power order is. Tell me, what is the penetration power order? Or shielding order? The penetration power order, S electrons greater than, P electrons greater than, D electrons greater than F. Third option also right only. The atomic radius of boron is more than beryllium. No, that is wrong actually. Beryllium is greater than boron. The correct statements are 1, 2 and 3. That means it is easy to remove 2p electron than 2s, and then 2p electron is more shielded from the nucleus, therefore it can be easily removed, and then the 2s electron has more penetration power, therefore option D is correct. Statement 1, 2, 3 are correct statements. So these are the some important questions regarding classification and properties of the elements in a periodic table. Thank you very much.